Alright guys, so welcome back to the part 2, and we have already done the cache of a flip simulation. Okay, so let's see how this thing is looking. So I'll just add a particle fluid surface just to visualize the particles, and I'll just change it to the particles as of now, and just click on this, visualize this thing as a velocity. Okay, and let me just connect this with the original geometry over here, and let me just go and change the points to the pixels. So you can see like we have got out a cache, and that is what we're having. And you can see like it's having really good details at 0.007 resolution. Alright, so that is what we have got. Let me just make a preview and let's see how this thing is looking. So I'll just go here and change the color a little bit and decrease the velocity range, something like 2. Okay, so let's just make a preview and let's see how this looks. So as we can see, like we have got some really nice looking details, and we have really good details over here, and the overall simulation is like looking good. Alright, so now we can start the meshing of our simulation. Okay, so maybe I'll just go to frame 168 or so, maybe a little bit ahead. Okay, so let's go to the particle fluid surface, and you can just connect the second and the third input. And what I'm gonna do, I'll change the influence scale to like 2 and the droplet scale to 0.7. So influence scale means how far a particle will look, like how far will it search for the another particle to connect two meshes, to connect two particles basically. And if you increase this number, you will have more smoother mesh. If you decrease this number, you will have more like noisy and detailed kind of mesh. So for large scale simulations, we tend to decrease this value, and droplet scale means like the p scale of a particle, so how thin or how thick the mesh is going to be. So we have already covered these kind of things in our basic series, so you can just check that out on the page. Alright, so I'll just change it to the surface polygons, turn off the visualize velocity, and let's see what we're getting now. Okay, so that is what we have, and you can see we are getting good details in our mesh too. Just turn off this visualize, and that is what we have. Okay, alright, so by default there are few issues like you can see on the edges, and this is because of the boundary layer. So if you go into the boundary conditions, so it creates a band. So basically we can just subtract uh, this area, we can just delete that edge kind of thing. So what you need to do is you just need to go into this regions option, okay, and you'll have to turn off the bounding box, turn on the bounding box, sorry. Let me show you what we'll have to do. So you'll just have, I'll just bypass this thing, okay, and I'll just open my box parameters and I'll connect it with my particle fluid surface. So turn on the bounding box, connect the size, connect the center. Okay, now what it's going to do is it's going to use this box as a boolean to cut out anything which is outside of this mesh. Okay, and you can just turn on this closed boundaries. Let me just turn it off first and let me show you how it looks now. Okay, so if you look at this, we have got a very thin sheet layer of the particles and we don't have anything below this. So what I'm gonna do is I'll just turn on the closed boundaries and we will just get a box. Okay, so we are just back to what we were before. But the cool thing is, because as I said, like this is working as a bounding box, it's working as a boolean. So we can subtract something from the edges. So let me show you what I'm going to do now. So I'll just disable this node again. So right now, just pay attention to these lines. I'll just bypass this and I'll subtract some value. So from the x-axis, I'm going to subtract a value of 1. So I'll just do a -1. So it's gonna cut an edge of value of 1, and I'll do the same with the z-axis. Now if I turn on this node, let's see. And if you see, we have successfully got a very clean edge. Now value of 1 was like kind of big. We can decrease it to like 0.3 or 0.4. That will also work fine. Okay, alright, so I think that is it for the meshing. We have already done our meshing. There's like just one more thing that we can do, and especially in the areas where we don't have any movement, the flip, like because of the way, like, it tries to make the simulation faster by adding more particles where we have the movement based on reseeding. So we always get some like kind of noisy mesh in the area where there's like no movement. So you can see, like, we don't have anything like that over here. We have all the details, but as you go away from the main action area, we have these kind of noise. So a way to fix that is just go to the filtering, click on this visualize mask, click on this velocity range, and you will see, like, wherever we have velocity, we will get a mask. So basically the higher velocity areas will get this kind of blue color, and the lower velocity areas will get this red color. So it's creating a mask basically based on the velocities. Now what you can do is you can just turn on this smooth value. So by default it's going to smooth out everything, so it's going to add a smooth filter on everything, and we will start to lose the detailed mesh. But the cool thing is, if you turn on this mask, it's only going to act on the areas where the velocities are low, hence preserving the details and removing any noise, especially which is in the area where there's like no movement. And you can feel free to go to a value like 10 or so, and let's see what we get now. Okay, so if you see, we have completely smooth mesh over here, and over here we don't have any smooth mesh, and that is preserving the details. So if you uncheck this visualize mask, that is what we have got, and I think that looks good. Alright, so the next part is to cache out our particle fluid surface as well. So I'll just do a control C and control V for the flip cache, and now all that we need to do is save out the mesh as well. So I'll just click on this path. I'll just go to a new sorry. So now I'll just click on this path, and let me browse it to a new path, and I'll make a new folder. I'll call it mesh. Go inside this, just type something like $f.bgeo.sc. that is the default file format for compressed cache. And all that we need to do is just click on the save to disk, which is going to save out the mesh. Okay, so I'll be doing this after the video. You just have to click on the save to disk, and it's just going to save out the sequence for our mesh. Okay, so it's as simple as that. So we are going to cache out the flip particles, the particle fluid surface, we will make the whitewater source, and then the whitewater. So we are going to have around 4 caches. Okay, so now all that we need to do is click on this save to disk button, and it will start to save out our mesh cache into the directory that we have defined here. Now that will take some time, so I'll just pause the video and we'll get back and we will start to work on our whitewater. Alright, so the caching is done. I'll just null this out and I'll call this mesh. Okay, so we are going to use this for the rendering later on. Now what I need to do, I'll just come out from here, from this flip cache, and like we can just keep this aside over here. Okay, and let's start to work on the whitewater source. Okay, so in order to create the whitewater, first of all we need to define the sources from where the whitewater is going to come out. So just press tab, add a whitewater source, and again it requires the liquid simulation which comes from here, and then it requires the container and the collision, which once again we don't really need. So even without that, it's just going to work fine. Okay, so I'll just go to some good looking frame just to see how our sources are getting created. So I'll just change it back to the particles just so that I can visualize them properly, and go to a frame where there's like kind of good movement. Okay, so yeah, that is fine. And if I click on this whitewater source, let's see what we get. So it's gonna create some sources of the whitewater. So let's look at this, what we've got. So sometimes whitewater, it's not really visible on the viewport, but like if you see, it is there. So all that you need to do is just click on this I button, and you can see like we have emit field from where the white water will be emitted, surface field to know where the flip particles are, and velocity field to move the flip particles, sorry, the white water particles based on the velocity field of the flip. So if you want to like make the visualization better, you can just use a volume visualization and click on this volume visualization. By default, it won't work. You'll just have to change the density field from the density to the emit. And now if you increase the density scale to like value like 100 or so, you'll see we'll start to get these, little boxes of volume. Now all that you need to do is, just so either you can just connect your Whitewater, the second and the third input, but I've seen like, that thing like, just makes it a little bit slower. So I can just, manually connect the particle separation value. So I'll just do a copy parameter, go to the voxel size, and I'll do a paste relative references. So it knows on what voxel size we are working now. Okay, so you can see that is what we have got, and these are the areas from where the Whitewater is going to get emitted. So if we look at some of the options of the Whitewater source, just make sure the voxel size is set to a correct value. I don't think you really need to change anything in these options. So speed range just means, so like anything which is below the speed of 2, it's not really going to consider those particles of the flip as Whitewater source. And in these sources, we have turned on the curvature, acceleration, and the vorticity. So these are the three values from where the Whitewater is going to get emitted. So once again, if you want to know more about these little things, you can just go back to our masterclass for the Whitewater. I've shown like, what all of these settings do. Now we don't really need to change anything else. It's all fine. In the visualization, I've just connected the Whitewater scale. Again, that is for the that is for looking at the particles. We are not, interested in the particles. Just the volume is kind of fine. Okay. Now again, same thing. I'm just going to cache out the source for the Whitewater as well, because it just takes forever if you don't do that. So like I'll just do a Control C and Control V again. Just connect this over here. And let's open the path. Now I'll just make a new folder, call it Whitewater source. Just go inside this. Again, same thing, $f.bgeo.sc. Okay, and I'm just going to click on this save to disk. So now this is going to save all the frames for the Whitewater source, and then we are just going to load that cache back. So let's wait for this, and I'll be back when it's done. Okay, so the cache is done, and I'll just call it Whitewater source. Okay, and just to visualize this again, I'll just connect it with the volume visualization, and you can see that is what we have got. So these are the areas from where the Whitewater is going to get emitted. Okay, and again, if you want to see it with your crack, just put down a merge node, and this way you will know the areas from where we have lots of churning and lots of movement and lots of turbulence in the water, and from where the foam is going to come out. So you can see, like all the areas from where there's like a lot of movement in the water. So these are the areas from where we are going to emit the Whitewater. Okay. All right. So yeah, so that is just for the sources. Now let's go to the actual simulation for the Whitewater. Okay. So for that, what I'm going to do, I'll just add a Whitewater solver directly. Okay. So let's just keep them like this, and just remove the volume visualization. Just go back to the first frame, connect this source into the emission tab, and now I can just connect the fluid compress and the collisions. Okay, now again, you don't really need to put any collisions because collisions are just coming from down the line. Okay, and it is important to connect the container and the collisions, because like if you connect the container, it knows the boundaries. Okay, so if I just go to the frame 1, so that is what we have, and let's just do a sim. Before starting the sim, I'll just do few stuff. So as I we have talked about in the previous series as well, that Whitewater scale is like completely independent of the Whitewater, like from the flip simulation. So you can put any values here and it will just work on that resolution. So basically what I do, I just connect both of them and just multiply it by 2. So it should be at least twice, the voxel size should be at least twice of the original Whitewater scale. And let's do something like 0.02. And before starting this sim, I'll just do one thing. I'll just go to this foam tab and I'll turn off this density control. However, for the final thing, we are going to turn it on. But as of now, I'll just turn it off because this is like very CPU and RAM intensive. And let's just do a sim and let's see what we get now. Okay, so if you look at this, that is what we have, and we are getting the Whitewater over here, and that is what we are having. Okay, so I'll just turn off this show collision, otherwise it's going to be like very slow in the viewport, and that is what we are getting. Okay, so we have some nice foam movement, and some the foam is moving with the flip particles. And before, like previously, we used to we'll have to connect the emit field, and then we'll have to bring the volume source. It's all gone for good now. Okay, and now let's go to the setup and let's look at all the options. So you don't really need to change all of these things, they are just fine. Go to the physical, we don't need to change anything. In the emission, generally I like to keep the maximum initial speed to a lower value. So this means like a whitewater particle can be as much as the flip particle. The speed of the whitewater particle can be as much as the flip particle, but it cannot exceed like 0.2 times of it. So sometimes whitewater, they start to overshoot, so it will make sure, so this is working as like kind of a pop speed limit. So it knows, so obviously if the flip particle is very fast, the whitewater particle will have the influence of the velocity field, and it's going to move as fast as that flip particle, but it will never go beyond 0.2 times of that original speed. Okay, so I'll just put it to, you can put it to like around 1 or so, but I think any value like 0.3 from 0.1 to like 1 is completely fine. For the lifespan, I'll change it to like kind of maybe 2, and that means all the flip particles, sorry, I keep on confusing myself. So all the white water particles will die after a lifespan of 2. That means 48 frames. Now let's go to the forces. Buoyancy means how fast the particles will rise when they are under the water, which is completely fine. For the base advection strength, I like to keep it to a value like 100. So this will make sure that our white water particles, they advect the, they inherit more velocity of the flip particles. So like what's going to happen is they're going to really stick to the white water, and this is like really good in medium scale kind of simulations when there's not lots of mist. So obviously if you have lots of mist, this will make very like kind of thick bubbles, which we don't really want. So in these kind of simulations, if you increase this value, you will have very good looking movements in the white water. Okay, now let's go to the foam tab. Again, base velocity multiplier is completely fine. Let's go to the foam tab, and the first thing that we want to do here is like the play with the repellent value. Now the only thing that I like to do is go to the feature size range, put it to like 0.02, and for the maximum size range I'll put it to like maybe 0.06 or so, or maybe 0.1. So this means how big and small the shapes in the white water will be. Again, as I said, if you want to know more about these things, just go back to our basic white water series. You'll be having all the info about these things. Okay, I'll just go to this advanced tab, and I'll turn on this match radius distribution, and I'll make the so this across this line, it means like the size of the particles of the repellents actually. So this value means the left value, which is 0.02, and this like graph means the maximum value of 0.1, and the y-axis means the distribution. So if I put this something like this, so that means we will have lots of small particles, and then we will have few of the big repellents, and then we can just add something in between like this, and this way we will have repellents. So repellents are the foam structures, foam patterns which are caused inside the foam. So once again, just refer to the older lessons. Okay, and I think rest everything is fine. And yeah, so in this control range, I'll just put it to like 0.1. So what it does, it snaps the white water particle to the flip particle. So if you have this very high, they're just going to get snapped to the white water and flip particles, and we might get some flickering. So a value of 0.1 to 0.2 is like completely fine. Don't decrease it too much, otherwise they won't follow the movement of your flip particles. Okay, and I think that is fine. So again, right now density control is off. Let me just do a simulation, and let's see how it's looking, and then we will turn it on and see how it looks. So let's put it to like 0.01, and let's do a sim and let's see what we get. Okay, so if we look at the output, that is what we have got, and you can see like the foam, it's really following the flip particles really closely, and we are getting these nice patterns, and they are also dying off, which is kind of good. Also in the Whitewater solver, here we have this option in the foam to enable the erosion. So right now you can see we have these lone particles which are not really dying. So if we turn them on, turn this option on, it's going to like, kill these lonely particles. Okay, so we'll be doing that now. And I don't think you really need to change anything in this enable erosion. Like everything is fine. If you increase the erosion strength, basically it will, be more intense. And I think I'll just do one more sim, and this time I'll just, change the Whitewater scale to like 0.005. Also make sure when you do the final sim, always turn off the cache memory. This way you will save lots of RAM. Alright, so let's just see what do we get now. Okay, so if we look at this, that is what we have got, and I think that looks really nice. But there's one very big problem, and that is, we are getting these kind of thin streaks, and that is because right now our Whitewater, it's working like, infinitely small particles. They don't know about each other, but if you look in reality, so basically foam is nothing but just small bubbles, and bubbles, they have pressure inside them. So they are like air bubbles, they have air inside them, and they, like have kind of this volume thing. So they cannot just converge into the single kind of infinite infinitely thin line. Okay, and that is where our density control comes in. So if you enable this density control, and I just increase this constraint stiffness, that means how stiff the constraints will be. So basically now all the particles, they are going to know about the existence of each other. And now if we do, so once again, this is like kind of RAM heavy. So just make sure you turn off this cache memory, especially if you have low RAM in your PC. Okay, and let's do a sim, and let's see what do we get now. Okay, so if we look at this now, you can see like, the foam is like kind of having its own volume, and the bubbles are like kind of interacting with each other, and which gives it a really thick kind of feel, and that is what which really makes it look really, kind of realistic. So I mean, yeah, that is looking good. So there's just one more thing that you'll have to change, and let me show you what I mean. So if you go to the advanced options, here we have this neighborhood size. So neighborhood means how many white water particles are going to interact with each other. Okay, so if this value is set to 20, not more than 20 particles over here, like on each instance, can interact with each other. So one particle can only interact with 20 particles. Okay, if we increase this value, basically we will have more bigger clumps, so you will never see any single particle of a foam or white water or bubble alone. Okay, so that is because we have lower size for this thing. Okay, so we can just increase this value to get more clumpiness in the water. Let me show you what we're going to do now. So I'll just make a preview for this thing, and we will compare it once we increase this value. Okay, so I've made a preview, and that is what we have right now. Okay, and now what I'm gonna do, I'll just go back here, and I'll just connect both of them. So it just means the size and the maximum size. So I think we can just keep both of them to the same value, and I'll change it to the 60. So now I'll just make a new preview, and let's look at the difference. So now what's gonna happen is, we will have more white water particles which are going to interact with each other. Okay, and that will, you know, uh, like save us from having those single lonely kind of bubbles, which looks very unrealistic. Okay, so let's do this sim, and let's see what do we get now. Okay, so if we compare both of them, let's see what do we have now, and let's play both of them now. So you can see like previously we had this lone particles, but now if you look at the new sim, let's try to spot the difference. So again, if I go to the frame 26 and all, see, so that is what we have now. So these particles, they will try to clump much more. See, so on this frame, you can see that is what we have got previously. See, like they are not really having a defined wall around them, but over here we have a more defined cellular wall around these foam areas. Okay, again, if we go to frame 37 and so on, so again you can spot like we have kind of stronger walls around the particles, and it's really going to avoid these small little lonely particles. Okay, I think that is it for the Whitewater. And now we are just going to cache this out in the same way like we have done everything before. So let's just go back, and I think for the final thing I'll be going around 0.003. Okay, so I'll just get my Whitewater source. Let's do a control C and a control V. And before caching out my Whitewater particles, I'll just use an attribute delete, and I'm going to delete the velocities from here. So over here I'll just write V. So it's going to delete all the point velocities from my Whitewater, which is going to save a lot of disk space, because I am not really going to render out this thing with the motion blur. Okay, and I can just simply go to my location and make a new folder and say Whitewater, and let's say $f.pgeo.sc, and I'll just click on this save to disk. Alright, so this is going to save the Whitewater now, and once it's done we are going to meet in the next part, and we are going to render out the mesh, the volume, and the Whitewater together, and we'll be rendering it out first in the mantra, then in the Karma CPU, and then we will go to the Karma XPU. Alright, so I think that is it. Let's meet in the next part. Bye bye.